So we talked about these internal qualities, external qualities of good quality software. Portability, we did mention portability, flexibility, we did mention. Expanding the system for other uses or other environments, for example, by having modular components. In other words, you may have like a module that allows you to work on Microsoft, and another module that lets you take the same software but run it on a different operating system. That would be flexibility or portability. That would actually be portability for a different operating system. But other environments, I don't know what exactly we mean by environments.
I mean, like different IDEs.
Maybe, yeah, could be. For other uses, or maybe you have modules that help you do, let's say, all the communication for credit cards, and then you can all of a sudden use that in a different selling, soap or selling something else. And you have modules that you can plug in and plug out and recreate your software. Portability means that to make the system work on different operating systems. That's generally what the word portability means. Different operating systems. Reusability, that the code can be used in the next project, right? We may contract it for this project, but we want to be able to use the same code again in our future projects. So that would be making the code reusable. So these are pretty general terms that are used in a lot of ways. Reusability, portability, flexibility. Okay. Now I took a quote from his book called Challenges of Software Engineering. So it says like this: software engineers are aiming at optimal designs, but quantitative criteria for optimal software design are unknown, are largely unknown. In other words, how do we quantify an optimal design? We want an optimal design, but we have but the quantitative criteria for optimal software design are largely unknown. Optimality criteria appear to be mainly based upon judgment and experience, which are intangible factors. So we need to define what we want to be the above quality parameters. Well, we actually just got, it's funny that I put this here because it's right before this, I listed a bunch of criteria that will make it optimal. Portability, right? We're trying to figure out some of the things that we're looking for. And here I say optimality criteria are largely unknown. Quantitative. So what do we mean quantitative? Like, it's one thing to say it's portable, but it's another to say how portable it is. Let's quantify it. Let's give it a number. Is it 6% portable? Is it 20% portable? So we don't know how to quantify these criteria. That's what really we're talking about. Okay, these are just limits of engineering. What is software engineering? Now, these are different definitions. The investigation of an orderly method from the idea stage to the deployment stage to producing an accurate, valuable, and highly quality software. That's one definition, right? Investigate, in other words, you notice what it's saying here? The investigation of an orderly method. In other words, it's a research topic called software engineering, which we in university can do, which is to investigate what would the orderly method be. To do, how do we write the investigation of, like get a PhD in software engineering, because I investigated it. I did studies of what projects succeeded and what companies succeeded. In the Pressman book, I found this, the establishment, I don't know what I meant, I don't know what the Pressman book means. But anyway, I found this, the establishment and use of established engineering principles to produce an efficient, affordable, and reliable software product. So this reliable, real software product. So this would mean following known principles to create software. That would be software engineering as a practice, not as a research subject in university. As a practice, it means following methodologies. IEE, IEEE, you heard of IEEE? It's like a standards organization. So it has a definition. The implementation of a systematic, so here it's talking about we're actually doing implementation of a systematic method based on rules, discipline. That is following a certain discipline, right? You're not following a discipline if you don't have rules, which can be measured quantitatively, quantifiably for the development, operation, and maintenance of software projects and research into the development. it combines these two. But we just said we can't do it quantitatively. Okay, so these are some different definitions, but basically we see there's two parts. One is the investigation in university of how to do it, and then the other is following certain rules that will lead to reliable software. What is a project? A project is an organizational campaign to produce a unique product with a rigid time and resource constraints, right? As we know how long it's going to take and how many resources, how many people, how many computers. The life cycle of a project. Commonly used term refers to the stages in a project. Recognizing the first stage is one, recognizing the need, then come up with an idea for a solution, then actually creating a solution, then deploying it on people's computers. There's actually a whole field called DevOps, which is about deploying. That's basically what they do, is they deploy they make sure it can be deployed also in the development, but they also do the deploying of the software onto machines. I don't just mean download. In other words, they make sure that it's downloadable, that it can be downloaded, that it will work for different systems.
So DevOps don't come up with code.
What?
They don't come up with like the code.
In general, DevOps does not write code. They're more like system. They're a combination of a few things. They're systems people. They also do integration between the QA and the developers. They make sure that the company is using the right technology, that they're all using the same technology. They're integrators. They're kind of integrators of all different parts of the company, and that includes deployment. Using it, then the software needs to be used. Then improving and modifying it, changing it, right? Microsoft is constantly changing their. The life cycle ends when the program is no longer in use. We kind of said this already. Support may have ended earlier. So here we're saying that just the fact that we talked about death being that I stopped. Yeah, probably right. But you're right. The life cycle ends when the program is no longer in use. But not when the support has ended. Okay, I don't know. A little bit fuzzy there, I would say. Because the project, I mean, if the people are using it in Timbuktu, that means my project is still going on. Doesn't really make sense. Well, these are certainly part. Yeah, you're right. There's sort of overlap. Design process, SDLC, structured development lifecycle. This is a design process called SDLC, structured development lifecycle. Define stages to develop the project. First, you define what the stages will be, right? You need to define. I'm going to have this stage. I'm going to have the infrastructure stage. This, this stage. I'll have different stages. What to do in each stage, how to do each stage, what will be created in each stage, and how to move from stage to stage. It's very important to have stages in your project to figure out, to plan out what the stages are. You can even have different teams working on different stages simultaneously. If you think about it, if I come up and I say this section of the program, what does modularization mean? It means that I'm going to have a certain section of my program which is going to have an interface. You ask for this data and you'll get this data. You ask this with the inputs and this with the outputs. I haven't yet written it, but I know I defined already on a document what the inputs and the outputs are. So now I can have one team write that section. And then I can have another team write a section, assuming that section exists, assuming that they can get that input and output, and they don't have to write it. It'd be like you have different functions in your program. Once you have different functions, you can give each function to a different person to write. As long as you define the prototype of the function, you say, don't change this. This is the prototype. So then the user will know that's what he can give and that's what he can get. And the writer will follow that plan also. So you can design your software in stages and then usually stages are timed, but I'm saying that once you have these stages defined, you can do them simultaneously. But in general, stages means what's my first thing I'm going to do, what I'm going to do after that, and after that, and what I'm going to do in each stage. Okay. And now we talk about the waterfall. Why is this? Yeah. This is my slide here. I added a little bit to it. The waterfall model. The first formal description of the waterfall model is often cited as 1970 article by Winston W. Royce, although Royce did not use the term waterfall at all in that article. Royce presented this model as I think is very funny, as an example of a flawed non-working model, which is how the term is generally used in writing about software development to describe a critical view of a commonly used software development. In other words, when we talk about waterfall, when we use that term in general, we're saying we're criticizing people who use it. If we're in favor of it, we wouldn't really call it. But now it became people say, oh yeah, I use waterfall, but it was originally proposed as a thing to say what's wrong with doing it this way. Even way back in 1970. The earliest use of the term waterfall, actually as that term, may have been in 1976 paper by Bell and Thayer. I just got this from Wikipedia, I think. In 1985, the United States Department of Defense captured this approach. They actually adopted this approach in DoD, Department of Defense, Standard 2167A. So in other words, they actually wrote that this is the standard way of doing things. Or they wrote a standard for waterfall. Their standards for working with the software development contractors, which stated that, quote, the contractor shall implement a software development cycle that includes the following 6 phases. The software requirement analysis. In other words, figure out what you want to do. What are the requirements? Then a design, preliminary design. Then a detailed design. These are different phases. Then we'll come with the details. And in each one of these stages, and as I'll check if it's correct, or I'll decide if I want to continue. Coding and unit testing. That's actually coding and testing. Integration. What does it mean unit? Unit testing means the different parts I test. Integration means I put all the parts together, and then I test the parts together. The idea of waterfall is we don't move upstream. We don't change the design once it is done because it's expensive to change the design. See, the Department of Defense wants the proper design, and then they're not going to go and rethink everything all the time because maybe they've already contracted to get the hardware for that design, and then they have to change, and they've already bought it. So in other words, they want to have a design and then start doing it simultaneously in different ways. So they're not going to reassess their design in the middle because it's too expensive to do that. They want to know what they're doing and then do it. That's the idea of waterfall. You'll see all kinds of pictures of waterfall. But I don't know if I have one. Do I have a picture of waterfall? No. Yeah. Well, kind of. Okay. Oh, this is the Department of Defense stages, but I got a little bit confused because then I started looking into these stages and I found other stages. This is slightly different. But this makes sense. Let's remember that. Requirements analysis. The preliminary design, detailed design, coding and testing, integration and testing. Okay, so this is another set of stages. Stages 1 and 2 are sometimes combined into one stage. System and software requirements captured in a product requirement document that we talked about, SRS, right? What does SRS stand for? Systems requirement software. Anyone remember? SRS?
Software requirement specification.
What?
Software requirement specification.
Specification. Okay. So that an SRS is an example of a product requirement document. Right? Because a more general term is a product requirement document because it could be like I could have a wheelbarrow have a product requirement document. How should it be? How many wheels should it have? How big should it be? How much should it weigh? Everything can have a product requirement document. Analysis. So we didn't talk about analysis before. And that resulting in models, schema, business rules. Business rules means like how I want to do it. But all this is analysis Then the design. So we see these two can be combined into one stage. Then the design, notice they don't have preliminary and then detailed design, they just have one stage called design. Design resulting in software architecture, or design how it should be built. Architecture means the stages, like, or the parts, the modules, how it should be built. Coding, the implementation, okay. Testing, systematic discovery of the debugging of defects. Operation, installation, migration, support, maintenance. I hope all those terms are clear to you, what that means. Installation, installing it. What is migration? Getting it, let it move from, it should move from one place to another. Well, that's what I think it means. It means going from different computers, like down through the internet. Maybe that's what it is. Downloading. I'm not sure what migration is. All right, advantages of waterfall. Easy to plan. Well, it may take a year to do it, but it's easier to plan than if you don't plan. Than if you, in other words, you can actually plan. Easy to manage. Managers are pleased with it. In other words, managers like it. They have a document. It says on January 1st, we're gonna do this. On February 1st, we're gonna have this. It's all, and they can go to the worker. It's 3 days till February 1st. Where is it? They can see and they can say if we met up to our plans or not met up to our plans. They like that. They don't want just the program to say, we'll do it, just give us time and we'll just work on it and give us another week and we'll do some more features. And we don't know when we're going to finish. We'll never finish, right? If you think about it, Word has never been finished. When is Word going to finally finish? It's never finished. It's always just more features, less.
You haven't even made it a subscription, so you know.
Right. It's like when does the New York Times finish? It never finishes. We just keep working on it. When does what's his name? Charles Dickens. When is he going to finish that book? You know that he was paid for the Word. That's why his books are so long.
Yeah, back when they published it like that.
He published it in serial form in newspapers. So he just added more and more chapters and more things. Why just keep going?
Same with Conan Doyle.
Yeah. Oh, but those are short. I mean, Sherlock Holmes, but they're short. That's different. But at least they're finished.
He killed them all.
What?
He didn't want to write anymore. He killed them off and then they brought him for tested, so we had to bring him back to life.
Oh, yeah?
He's trying to get rid of the character.
Sick of writing it?
Yep.
All right, so managers are pleased with it. They like waterfall because they can see. Stages are clearly separated. They have defined finished products. There's what should be done at stage 3 of the program. You know, we should have this and this done. We should have it. And then I can know on January 5th, this and this will be done. We have milestones. Everything is documented. We know what we're going to be doing ahead of time. Government bodies like it because you can contract out software and have an exact contract. You know the price tag and can compare bids between competing companies. It's very useful. The only problem is there was a problem with it, that it can be all wrong, that it can be all impossible to do. But at least we have a plan.
Bodies are just big versions of managers.
What?
Government bodies are just big versions of managers.
But they need to manage. You need to make a contract. You need to hire. I was just listening to something. There's a book by Michael Oren about the 6-Day War, and he wrote about 10 years ago. And he writes there about a general giving a speech before a war, and he says, in all wars you have to be prepared. Nothing will go according to plans. But he says, but the main thing is just kill people, you know, just fight and fight and fight. But he said you can't, don't expect things to go according to plan. But here we're trying to make a plan. Okay, so that's waterfall. So these are the advantages of it. Disadvantages of waterfall. Long development time. In other words, we may spend a year planning before we actually start coding anything. There is little contact between the consumer and the developer after the initial requirements analysis. In other words, there's something called the requirements analysis, which means that we send somebody over to the people who are going to be using the software, and they just have a conversation, and they find out what do you need, how are you going to use it, and they document all this, and then they interview many people, and then they come up with a document, and they say, okay, this is what we understand you guys need. And then they give it back to them. And then the manager reads it and checks if it makes sense. If if it's really if he did a good, he talked to all the people, did he really understand correctly? And we want to have a contract, we want to have a conceptual contract, so I have the same conception as you do. So that's the requirements analysis. Can result in disappointed customers, but it could be I got it wrong and I don't change it. There is little contract in and the developer, there's after this point, and then that can result in disappointed customer because maybe even though he said that's what he wanted, maybe he realized he made a mistake, and he can't change it at the end. You only get the system at the end of the process. Now, you don't get the system in piecemeal, which could be good. It could be nice to have some of the system already up and running, and then I just get some more features later. But here you get everything at the end. Testing is held off till the end, and you don't really test it properly until the end. You might find that nothing is working. You might have all these different parts, all the unit tests work. You put it all together and nothing works. If something was misdesigned at the start, it will be hard to go back and change it. And if you figure out that you made a mistake, it's going to be hard to go back and change it because everything is dependent on it. All the other people are assuming that you're doing this in this way. And if you're now asking you to do it differently, then everything's going to change. There is a lot of uncertainty about whether it will be a good product. Now, we don't get any feedback along the way, so we don't know if it's going to actually be a good product. What do I write here? Cost of correcting an error in what's it called? In waterfall. So the cost will be 1 times 1 unit. I don't know what the unit is, but the basic idea is that if you try to change things as time goes on, as you get to the production stage, it'll be 1,000 times more expensive to change things. Now, the earlier you can catch an error and fix it, the better. As time goes on, it'll be more expensive to change. Yes?
Are you recording?
I am.
No.
Although I hope nobody's going to listen to me twice.
Yeah.
When to use it? So when do we want to use a waterfall? When the system is very fixed and certain. When we know the exact technology we want to use, because we know everything about the software domain. If we have a large team and people with knowledge, if we have a large team and people with knowledge may leave and new people may join and need to learn the project, having everything documented prevents loss of information and shortens the time it takes for new employees to become productive, right? If we have things documented, then if people quit, we can get new people in, especially if we have a big project, we have thousands of people working. If we're Tasia Avirit, we're Israel Industries, and we have aircraft industries. So we have thousands of people working here, and people are coming and going constantly. We need to have everything documented so new workers that come in will have something to read and understand what's going on. So it's certainly useful. You can't really document a system that you design to be constantly in flux. If the system is designed to change every week because we get new feedback when we change things, how are you going to document that? You can document it afterwards, but you can't document it beforehand. You don't know what the changes are going to be. So how are you going to teach new people to come in? You want to send them on a 2-month course as soon as you hire them to learn what the software is going to be doing. You won't have a 2-month course because you haven't documented anything. So you do want the waterfall. If we can find bugs in design stage and not have to deal with them later, that will save time and money. So if we do a really good system analysis and design over here, then hopefully we won't have any bugs. If we have really good analyzers or designers, architects, then we'll do it all right and we won't have bugs. If we don't, we just start coding and then do feedback and we'll constantly have bugs and new bugs and adding new features. So if we have good people doing it who are experienced, we can save time and money. When not to use waterfall. Don't use it if you expect a lot of changes coming along the way. The person you're contracted to knows that he doesn't know exactly what he wants, and he knows he's going to be changing his opinion. Or if you are charting new territory, you're doing some kind of software that's never been done before. So you can't really plan it. So you can try to plan it, you can waste your time. Clients may not know exactly what they want until they see the final product. If you think that the client is going to realize, oh, that's what you meant, that's what you're gonna do. Ah, now that I see that, I wanna do it differently. So don't do waterfall way. The designer may overlook some edge cases, and so you have to redesign anyway. So that falls into the category of the designer has to be a good designer. So then there are agile methods. I never know whether agile, it's always a little bit of a debate, whether agile is a method or a set of methods. But the different methods are all can be called agiles. Is an adjective, is agile an adjective or a noun? That's what I, see what I mean?
There's agile development, so that's an adjective.
In other words, there are many types of agile development, but then there's something called agile. You see what I mean? The agile method. Anyway, agile methods, so here I use it as an adjective. Agile methods versus waterfall. So what are agile methods basically? Use iterations and resign all the time. No, that should be redesign all the time. Redesign all the time. You're constantly redesigning. There are several agile methods. So here I'm saying, so Scrum is one. So an agile method is called Scrum. That should be capitalized. So you've heard of Scrum? No? So Scrum is, you heard of Scrum?
Only in sport.
In sport, right? What is it in sport? Like rugby or something. Right? When you get together and you plan something. So a Scrum, the idea is you have in the morning every day you have like a 15-minute meeting, and you plan out what the team is going to do that day in the program, the programming team.
Like a team powwow before the day.
Yes, it's a powwow. Yes, exactly. But no smoking of tobacco in a long pipe. And you plan out what you're going to do, and you also write down, like you usually, like the original way they did it, we actually did it, was with actual Post-its, those yellow Post-its, and you write on them all the different, you write on like on the board, Nachum, Moshe, David, Daniel, whoever is there, and you write a line, and then you write all the features that you're going to want over, you put them, all the Post-its are over on the left side of the board. And then on the right side of the board is finished. And so then I'll take a Post-it and put it under my name. It means that I'm working on that feature. And I may even have like under my name set stages, like started, in the middle, then nearing the end. I don't know. I may have vertically. But essentially I'll just put it under my name. And then somebody else will take a different Post-it and put it under. So at the powwow or at the Scrum meeting, we'll maybe decide, Nachum, you do, I'll volunteer. Really, it's usually on a volunteer basis. I volunteer to do this feature. And this one says, I'll do that feature. And it's a kind of like pride, if you say, well, I just will volunteer. I'll volunteer to make a coffee. So you volunteer for something, and then you take that thing on yourself. You don't have to have it finished over here. You could have like started, middle, and then finished at the bottom here. If you want to show that I finished it. You want to show how many things Malcolm did, and that may last on the board for a week. It's not like every day there's new features.
There's a website that does that now.
What?
There's like websites that do that.
And then nowadays, right, exactly. Nowadays, instead of physically doing it, you have a software that does it.
So you always see it through the computer, so you can't rub it in anyone's faces.
Well, everyone else sees it.
Everyone else sees the same. You all see the same.
Person.
But you see all the same thing. But it's better. It's kind of better on the wall because you have walls in your office anyway, and it's a way to use the wall.
It's more attractive.
And you see it there. You walk in, and and then in the next meeting, you're right there. You stand next to the wall, and you say, "Oh, Nachum, how's it going on that feature? It's been. We noticed that it's been in the initial state by you for 2 days now. Have you made any progress? Can we help you? Maybe." So you'll have that. That's what you do in that Scrum meeting. You discuss those features that you're working on, how it's going, and whether you need, what problems you're facing, or whether you need help, or whether you don't need help. So that's Scrum. Requirements may be defined by fixed time and resource requirements. So in this agile method, we still may say we have fixed times. We want to finish this. We want to have 3 workers. We want to do these features. We want to get it done by this date. We may need to produce something by a certain time and be forced to remove, this is what I said to you before. be forced to remove one of the product features to meet the time requirement. Remember? That's what I said, that's the best solution. That's a big, to me, it's a big chiddush. Because you would think, no, just give more time. And no, just, it turns out it's better not to. Or give more people. Later, we will add the feature and make another release. And we have this concept called a release. A release means we finish a set of features that are ready, they've been tested, and they're ready to be put in the new version. And we may have constant, we think of like Microsoft has new releases like maybe every month or 2 months, but you could have releasing every week, every 2 weeks. This constantly updating of your software. This works with the internet. It didn't, when Microsoft, you had to go and buy the disk in the bookstore and bring it home, then you would have a new version every year or so, or 2 years. But when we have the internet and you buy it and you can download updates all the time, then we can have releases, we can have continuous, every day we can have a new release. So, what makes a release? It's when we've implemented a set of features that we originally decided we wanted to implement, and we've tested them, and we've determined that they're ready to be released. But we can add another release if we didn't finish. We want to get something working and out the door as soon as possible. That's the idea of agile, as opposed to the waterfall. We want to get something out there. So in other words, you may build your system in a most rudimentary way, have some most basic functionality and get it out. And let the client already see it and see if it's already doing kind of what he wanted. And then you can add more features. In waterfall, the requirements are fixed, and we may have to add time or resources to meet those requirements. Right? In waterfall, we can't do that because we have only basically one release. So if we need to get there by that time and we don't think we can do it, we're gonna have to add more people, which may actually slow us down. How much more? Oh, I might. Wow, see how good I'm planning? I have 3 minutes and 3 slides. Right, we just did that. Okay, creating value in waterfall versus agile. This is, yeah, it took me a while to understand this. I didn't draw this diagram, but this is value. In other words, when do we get value? When do we get something valuable? So in waterfall, you got to define, you got to build, then finally release, and then you got some valuable thing, only at the end. In agile, this is time, right? In agile, you define, you build, release, you get something of value. Define, more define, build, release. You keep getting some value as you're going along. If everybody quits right here, you already produced something valuable. If everybody quits right here at the same time, you got nothing. You don't need to show for it. Now, what does this risk line mean?
What risk line?
People
This
might
red
not know
line.
their stock.
Is there the like risk of like changes and stuff?
Or risk of people not liking it and then you can change.
Yeah, it goes up. This goes up here. I guess whenever you have a release, it could be broken. I'm not sure exactly what it is.
Maybe like the other slide where like it was like the cost of the error, right?
Yeah, I was thinking maybe there's an error here is not so bad. An error here is more bad because it's already been released. Okay, I'm not sure about the red line, but yeah, something like that. I'm not sure about the red line. I didn't draw this diagram. I'm like you guys. I'm just trying to understand. Criticism and criticism.
Comforting.
What?
So that's comforting.
Yeah. No, I mean, I understand. Whatever. Nothing is fully understood in this field, so it's okay.
We learned while we were studying for our exam in software engineering. When we were studying for our exam in Intro to Software Engineering, we learned that there's a lot of opinions and nothing really defined.
Yes. So there you go. I agree with that. That's my opinion. Criticism and difficulties with Agile. So now we have to talk about what's wrong with Agile. For Bill Gates, so this is a joke. For Bill Gates, the users are his quality assurance personnel. In other words, he's supposed to hire people to test the product. But Bill Gates' theory was you just ship the product, and when people complain, then you know what to fix. So he saves money that way. So for Bill Gates, the users are his quality assurance personnel. In Agile, in other words, that's the problem with Agile. That's a joke, but that's what Agile does. It basically says, let's get something out the door and then we'll get feedback. Feedback is a nice way of saying, they're telling us what's wrong with what we did. I mean, right? And sometimes feedback is just telling us that we made a bug, we have a bug. Sometimes feedback could be we need a new feature, but that kind of feedback is feedback. But sometimes feedback is telling us we have a bug. In Agile, we still need a good and expandable design. In other words, it's not like we're exempt now from doing a design. We still need a design and we need to expand it. We need to be able to add features to it. We need a good design. We're still going to need a design. So it's not like we avoided the design stage. It's just that if we screw up the design stage, we're not in such bad situation, but we still need a design. It might be harder to design a system that can be implemented peacefully. It may in fact be harder to design a system, right, that I'm gonna have to build in this way. Wait, last line. Brooks' Law. Oh, this is what I talked about before. This is from this book. There was this book that I heard about a long time ago, and I never read it, called The Mythical Man Month. And it was very weird because it sounded like you're saying the mythical mammoth, right? The mythical mammoth, I thought it was. But the mythical man month. What is a man month? Anyone know what a man month is? A man month is like how many men working for a month will you need to get this project done? You measure projects in man months. It'll be like a what?
It's like the light bulb joke, you know, how many X does it take?
Yeah. No, it means like this project will take 100 man months. What does that mean? It could be I'll hire 10 people, it'll take 10 months. It could be I'll hire 100 people, it'll take 1 month. It needs 100 man months. It could be I'll hire one person, it'll take him 100 months. But it needs 100 man months. 100 men working for a month on it. Now they changed it to people. So now it's people months. But then the book, then it sounds a little weird, people months. But anyway, that's the idea. So what's Brooks's law?
What's an incremental person?
What?
What's an incremental person?
A new person. Wait, let's go slow. Let's just read the whole slide. So Brooks's law is this. This is the guy who wrote this book. Anyway, I was recommended, when I was like in high school, something like that, somebody recommended me to read this book, even though I was, whatever, or maybe in the beginning of college, I don't remember. At some point, a long time ago, somebody told me, read this book. I never read it, but it's like considered like a classic book of computer, not programming, but computer, like thinking about programming. Not the actual, not how to program, but thinking about programming. So if somebody's interested in reading it, bevakasha. But anyway, he's adding manpower to a late software project makes it later. And that I explained to you guys, right? The real solution is to remove features. Coined by Fred Brooks in 1975, so it's actually an old idea, but it's a kind of a bizarre idea. Adding manpower to a late software makes it later. According to Brooks, an incremental person, a new person you add to the project, when added to the project makes it take more, not less time. He needs to be trained, and training him drains the time of other workers. I told you all this. He will likely introduce bugs into the source code because because he doesn't know what he's doing. He's new. And that will require the good workers to go find his bugs and get rid of them, requiring still more time from other programmers. The solution, removing features, is a better way to hurry the project along. So that's the idea already from 1975, but it's kind of an unusual idea. All right, so we finished slide section 1. Only 13 more to go.
Are you